Okay, so here in imidazole and thiazole, okay, it's a one nitrogen and one sulfur containing 5-membered ring. So these are the resonance form, and this will be the structure. Okay, so when you are writing the structure, you can mention that again here also common factor you can mention. The common factor is uh, cyclic, planar, conjugated, and obeys Huckel's rule, and it undergoes electrophilic substitution reaction. So this you mention common. In addition to this, you can also write the electronic configuration of nitrogen, electronic configuration of nitrogen, electronic configuration of carbon, and you can say that this undergo sp2 hybridization giving rise to this structure. That's what you can mention. So these are the resonance para, and I will go for a presentation mode. I will take, okay, I will go for a presentation mode. Right. Okay. I will take a pointer. Right. Here also the more particularly bromination occurs all the position, but whereas other thing maybe nitration and sulfonation occurs only at the 5th position. So overall what you need to remember as far as reactivity is concerned, in imidazole and thiazole, 4th or 5th position is effective, only one position. If a free NH2 is there, free NH group is there means 4th and 5th positions are equivalent because of the tautomerism. Okay, bromination, it is more active, so all the position is brominated. Okay, sulfonation, 5th position. Okay, pyrimidine, maybe you can give importance the occurrence. It is found in alkaloid called nicotinic acid. It's a good base and used as a catalyst. And it is also a component of vitamin B6 is called pyridoxine, and it is also present in niacin. Niacin is nothing but a nicotinamide, and also it is present in a sulfapyridine drugs. Okay, and this sulfapyridine is used as a pneumonia treatment. Okay, and this is the structure, maybe the electron configuration of nitrogen, unhybridized orbital which overlap forming a 3 pi bonds, and it has 6 pi electrons, and these are the resonance forum. And what is that you here, if you are looking, if you are saying about the basicity, so this can obstruct a proton, this proton from the acid forming a pyridinium ion. So this pyridinium ion is stabilized by resonance. Because of this property only, it is more base compared to the pyrrole, whereas in the pyrrole the lone pair is used up in a delocalization. That point you need to mention as far as the base is concerned. And since there is a lone pair on this nitrogen, it can react with tetrafluoro nitroborate and forming a compound like this. And sulfonation also, it is reactive. Aluminum chloride means alkylation at the N position, acylation at the N position, and if you are treat nitration of pyridine, 3 position. So this also a nitration example. Another example, this is pyridine, the substituted pyridine. So 3 is the position reactive in pyridine. So that's what you need to. Sulfonation at the 3rd position, bromination 3rd position, chlorination 3rd position. So pyrimidine, okay, pyrimidine also it is found in nucleotide, and it is the one of the bases of DNA. It is also found in B1, thymine. Okay, so that's what you need to remember. And it is used in many synthetic methods such as the barbiturates and HIV drugs. Okay, this is about the structure, more particularly electronic configuration of nitrogen and carbon. And you have to say that 6 pi electrons, 3 pi bonds, 6 sigma bonds forms. Okay, and these are the resonance form or canonical forms. And this is the reactivity. Okay, fourth position is the reactive place in pyrimidine. Okay, sulfur nitration, sulfonation at the fourth position in pyrimidine. Okay, nucleophilic substitution also occurs at the fourth position. Okay, electrophilic also occurs at fourth position. Nucleophilic also occurs at fourth position. And occurrence of pyrimidine. Okay, occurrence is important. Maybe you may get a 2 marks question. Pyrimidine is a derivative or the part of DNA base such as cytosine, thymine, and uracil. So what it means? It means cytosine, thymine, uracil are the bases of DNA. Okay, so these cytosine, thymine, and uracil are the derivatives of pyrimidine. Okay, then write the structure of pyrimidine bases. Means you can write any one of cytosine, thymine, or uracil. And this is again purine. So purine is nothing but a imidazole fused pyrimidine. And write the structure of purine bases. Means you can write this or you can write the pyrimidine structure. Okay, and then so purine is present in very occurrence. Means you can write this. It is present in nucleic acid, adenine, guanine, xanthine, isoxanthine, coenzyme A, riboflavin, and caffeine. Okay, so this is about the occurrence of purine. And these are the canonical forms. Okay, so this is the reactivity, eighth position. This position is called eighth position. Eighth position is the one reactive, and it will react at the eighth position, bromination or nitration. So right, so nucleophilic substitution also occurs at eighth position. So this is the indole. Indole, more particularly, the occurrence is important. So indole 3-acetic acid is a plant hormone present in essential amino acids. So tryptophan. So it's also present in alkaloids. It is also present in neurotransmitter called serotonin. It's an hormone used in perfume preparations. So this is about the structure. So here in this indole also you can write that it's a cyclic, planar, conjugated, obeys Huckel's rule, and undergoes electrophilic substitution reaction. In addition to that, you can write these parameters. So a 10 electron system. So how it is 10 electron system means the lone pair present on the nitrogen. This lone pair also is involved in a conjugation. This is 2, 2, 4, and then 6. Totally 10 electron system. Okay, and so bromination, third position in a 5-membered ring. Bromination or nitration or sulfonation, third position in a 5-membered ring. Okay, this is nitration, third position in a ring. Sulfonation, third position in a 5-membered ring. So this is again a Wills-Meyer-Hack. This is not Wills-Meyer-Hack reaction. It's a Riemer-Taymer reaction. So indole, when it is treated with the chloroform in presence of KOH, means a CHO group at the third position. It's called Riemer-Taymer reaction. I think you studied in your BSc itself. Even PU also, you can just look into the mechanism part. The mechanism part for you is not required. It's only the what is the product is formed. And this is also important. So write the structure of quinone. Quinone means you can write this is the one. So and mention the occurrence. Occurrence means you can a quinone structure means you can write any one, this or any of these three. You can write. Then afterwards, so you can if you want to look into the occurrence, it is it's a biological active molecules, and some serve as a electron acceptor. So some serve as an electron acceptor in photosynthesis. So that's what you need to mention. Suppose there is a question, what is the role of quinone in photosynthesis? Okay, it carries electrons. Okay, it acts as an electron carrier. So for example, ubiquinone, it's an quinone derivative one. Okay, it's also used, these are the uses. Okay, this is a pteridine moiety. This is the pteridine means this moiety is called pyrimidine and this one is called pyrazine. Pyrimidine fused pyrazine is called pteridine. Why it is important? Because it will act as a, it's again a 10 electron system. This is the structure, 10 electron system, cyclic, planar, conjugated, and obeys electrophilic substitution reaction. Obeys Huckel's rule. Okay, so these are the resonance forms, and this is again important. Okay, so pteridine, it's a precursor of dihydrotetrafolic acid. Dihydrotetrafolic acid is a coenzyme, part of the enzyme. Okay, which catalyzes the transfer of single carbon or 2 carbon from substrate to another one. Okay, pterine's compound containing pteridine ring. Okay, it is used in the degradation of phenyl, biosynthesis of neurotransmitter, serotonin, norepinephrine, dopamine. So these are the importance of this tetrahydrofolate or pteridine one. Okay, and one more important thing, this one. So normally they will ask, write the structure of isohaloxazine. So this is one. So where it is found? It is found in riboflavin, it is found in FMN, it is also found in FAD. Okay, these are the coenzymes used for the enzyme for the oxidation and reduction in the living system. Okay, this is the occurrence of this one. Okay, this is about what is called as heterocyclic chemistry, and these are the questions. I think you have these questions. Maybe what you can do, it's important that now onwards you just have a high on the question and answer. In addition to that, you can also have what is that question answer writing in a separate notebook, and maybe what you can do, you can have a, I think now if you have a notes, you can condense it, condensed notes, short notes, condensed notes, short notes, all those things you prepare. And if you have any doubts, you can ask me over a mail or even over a phone number. You can also do that. And next class, okay, next 2 class is a test. Okay, Thursday it's a test on free radical. Saturday it's a test on rearrangement. Okay, test will be only for the 10 marks question, and the 10 marks means one is 2 marks question, another 2 will be the 4 marks question. Write it and immediately you can send to my mail. I will evaluate. Okay, though this is about the next week tentative plan. Okay, so maybe what is that? What heterocyclic chemistry, stereochemistry, free radical chemistry. Okay, and then rearrangement, and then bioinorganic. Okay, these are the chapters. Maybe you need to look into the question answers and familiar with the concept. Okay, if you are not familiar with the concept, you can ask me. Okay, so this is about the thing. And say, look here, this is isohaloxazine. Okay, this there is many times you can you can have a high on this isohaloxazine because it's asked many times in the main examination. And this is also what makes pyridine an aromatic compound as well as a base. So why pyridine is aromatic? Because it's having a cyclic, planar, conjugated, and one which obeys aromatic rule. And it also undergoes electrophilic substitution. But what makes the base means in pyridine, the lone pair present on the nitrogen, it is free, it is not involved in the conjugation, delocalization. So since it is free, it can react with the acid, more particularly the proton. Once the reaction of lone pair with the proton, the obtained one is stabilized by resonance. Okay, so that is the reason this will act as a better base compared to the pyrrole or other heterocyclic compound. Okay, and outline the importance of pyrrole and pyrimidines. Okay, importance means again you have to mention the its applications. Okay, pyridine in biological system. Outline the importance of pyrrole and pyridine in biological system. So maybe I think I have mentioned, no? So maybe you can just look into this. Okay, so because it is used in many synthetic compounds such as barbiturates and HIV. And if you are looking at the vitamin B1, okay, this is the pyrimidine, no? Pyrimidine one, okay? Pyridine, pyrimidine. Okay, this is the pyridine. So pyridine and pyridine, okay? So where and all found? It is found in alkaloid. Okay, this is the importance and application in biological system. It is found in nicotinamide, and niacin. It's also called as niacin. Okay, and it is a good base. Okay, and it is used as a catalyst, and it is a component of vitamin B6. Okay, that's the thing you need to remember. It's also a sulfapyridine. It is used in a pneumonia. It's also a application of pyridine in biological system. If you are looking into the pyrrole, okay, where is pyrrole? Is the pyrrole. Okay, you know that pyrrole found in chlorophyll. Okay, so it's also found in vitamin B12. It's also found in alkaloids. Okay, it is a organic heterocyclic organic compound. It's having a 5-membered ring, and nitrogen will be the hetero atom. That's all. This is about the these are the things you need to mention as far as your what is called as biological importance. It is found in chlorophyll. It is found in vitamin B12. It's also found in alkaloid. So these are the points you can mention with respect to the importance of pyrrole and pyrimidine. Okay. Right. So give the structure of any one purine and pyrimidine bases. Purine and pyrimidine bases. Maybe you can write the structure of purine means purine and pyrimidine. Okay, bases thymine, cytosine, uracil structures you need to write. So what are the nitrogen heterocycles? Maybe you can take any one. So maybe pyrrole you can take pyridine, you can take pyrimidine, you can take purine. Okay, anything you can write, you can take and explain the aromaticity of the aromaticity and reactivity of pyrrole. So here this is the different question. Explain the aromaticity and reactivity of pyrrole. That means you have to explain the aromaticity of pyrrole. Pyrrole means nitrogen containing 5-membered ring. So in this pyrrole, the lone pair is involved in a delocalization. Okay, it undergoes sp2 hybridization, and maybe The common points, you need to write the electronic configuration of carbon, electronic configuration of nitrogen, and you need to write the structure, how the single bond formation, how the pi bond formation. Single bond means direct overlap forming, and double bond, pi bond means sidewise overlapping and forming a pi bond. Those things you can mention. And if you are looking into the reactivity means electrophilic substitution. You have to write electrophilic substitution reactions of pyrrole means at the second position, chloro, bromo, chlorination, bromination, iodination, and then also nitration, sulfonation, everything occurs at the second position. And pyrrole is aromatic and not a base. Because pyrrole is aromatic because it obeys Huckel's rule. Huckel's rule means cyclic, planar, conjugated, and the one which undergo electrophilic substitution reaction is called aromatic. It's not a base. Why? Because the lone pair present on the pyrrole is not free. It is involved in the delocalization. That is the reason it's not a base. So discuss the structure and aromaticity of furan and pyridine. So furan means oxygen containing 5-membered ring. So in this also the lone pair is involved in a delocalization. So in this what you need to do, you need to write the electronic configuration of carbon, electronic configuration of oxygen, and you have to mention that direct overlapping leading to the sigma bond, sidewise overlapping leading to the pi bond, and here the total number of electrons are 6 electrons, and it obeys Huckel's rule, and it is a cyclic, planar, conjugated, and undergoes electrophilic substitution reaction. That is the reason it's aromatic, and you have to write the structure. And pyridine also same thing, but here the lone pair present on the nitrogen is not free. That you have to mention. Okay, and here also you can mention cyclic, planar, conjugated, undergoes electrophilic substitution and obeys Huckel's rule. So both the point you can write. So write a short note on heterocycles. Maybe you can take anything, furan, pyrrole, imidazole, thiazole, whatever you can take all, or if you are taking all means you have to write little only, not completely. If you are taking one, you can write more clearly. Okay, then give the structure and biological importance of imidazole. So imidazole means 2 nitrogen containing 5-membered ring is called imidazole. Okay, that's what you need to write. And where and all its biological importance you have to mention. I think it is present in vitamin B1, thiamine is there, no? There it's present. Okay, and also it will act as a histidine. I think you know about the histidine. Histidine is nothing but a derivative of imidazole. Okay, so I think I have given in a notes, you can write down. And similarly, write the structure of quinone. Okay, quinone, benzoquinone, naphthaquinone, anthraquinone, whatever the structure you want to write it. How does it occur in biomolecules? Okay, means occurrence you have to mention, and it's also it is act as a what you call ubiquitin. Ubiquitin is the one it's occur in biomolecules. And one more thing what you can mention that these will act as a electron carrier in photosynthesis. That's what you can mention. So that's all about the heterocyclic chemistry. Maybe the maybe later stage. I think in stereochemistry, one thing maybe I will send the notes, more particularly the resolution. Resolution means if a container may be a beaker or a conical flask, if it contains a mixture of two isomers, it's called racemic mixture. From that racemic mixture, if you want to isolate one as a pure enantiomer, there are methods. Okay, so called crystallization method. Okay, crystallization method means you have to take a solvent in such a way that one of the isomer should go into a solution, other should come out as a crystal. Okay, that is crystallization method one can do for a resolution of racemic mixture. So thereby one can separate, okay, into two isomers in a pure form. Okay, another method, chiral reagent adding. If you are adding one chiral, if you are adding S, okay, it is possible to separate it, one as a solid, other will be going into the solution. Okay, there are enzymatic methods also to do a resolution. That material, it's about 5 marks question material. I will send it to your mail in addition to the bio-inorganic notes. Maybe today I will send the notes of bio-inorganic chemistry notes. In addition to that, I will also send the resolution method of separation of two isomers in a racemic mixture. Okay, so this is about the what is the more particularly I was thinking about the revision of heterocyclic chemistry. Leftover thing in stereochemistry is the resolution. That part notes I'm giving it, and maybe so all of maybe all of you can also inform your friends. So be ready for the free radical test. It's a 10 marks question that is on Tuesday, and rearrangement, it's a 10 marks question that is on Saturday. Okay, so this is the tentative plan. You be ready for that. Okay, I think if you have any questions, you can ask me.
Sir, the test is through app or through Zoom, sir?
No, just I will display the questions in a Zoom meeting. Okay, you write that answers in presence of your parents. Then afterwards, you take a photo or scan it, send it to my mail.
Okay, sir.
Right, that's what. So 2 tests, one is on Tuesday, another one is Saturday. So Tuesday's one is free radical. It's only the 10 marks question. 2 marks question, one question, 4 marks question, 2. Because it's around 6-hour chapter, no, that is the reason. Maybe I can also plan later stages for complete portions. Okay, maybe that I will do it later. Okay, at present I will have a 2 tests. One is on free radical, other one is on rearrangement. Okay, fine, no?
Okay, sir.
Fine, no? Okay. Maybe what I will do at this stage, maybe I think at this stage I will stop the meeting, I think. Okay. Maybe you can log out.